My name is Tony Woods. I'm the Managing Director of Midland Steel, and we're here today to talk about Tekla, what we've done with Tekla, and how we'd like to progress our company using Tekla. What has it given us so far to date? What does it work with in Rebar? Well, we have accurate and data-rich 3D environment, highly detailed and as-built information models, specialised solutions and configurations for the main contractor, the structural engineer, our team, and model innovation. Our services in Midland Steel, we provide a detailing, design and scheduling service to the BBS standard. We cut and bend reinforcement for all our clients. We provide express reinforcements, prefabrication of all rebar elements, which we'll come to and show you an example of later on, where we've used Tekla in a very, very efficient way. And of course, we provide value-added engineering. The reason we feel we're able to use Tekla more efficiently is we've been in the concrete frame industry also, so we have the added advantage of being able to demonstrate how concrete and steel works together, avoiding all the issues. By using Tekla, we were able to do that very, very efficiently. We can take from an architect the IFC file or 2D drawings, create and develop the Tekla model, and provide full rebar drawings in the BBS. We invest heavily every year in the most innovative machinery you can purchase and buy to fabricate rebar. We believe that by using the most experienced technology and the machinery, we will be able to serve our customer base better. So we've bought machines that actually bend automated 25 mil bar from 25 mil bars. That enhances our express service and gives us the same day collection available for our customers, which is very important in today's environment. We have live production in all our facilities with full computerized data traceability, from the original cast to the actual element of concrete that the bar of steel that we've cut and bent ends up in. So, what do? We get the model from the architect, create it, build it, start to detail it. We provide our scheduling from it, and it also then allows us to subcontract coordinate with the customer regarding the delivery. Tekla itself, on the concrete frame program side of things, provides the execution, the charge management, the resource planning, the quantity management, the procurement and the cost estimation. So it's an all-in package, combined and collaboratively working for us as a rebar fabricator and for the concrete frame contractor and the client. We provide working drawings and the BBS all generated from the Tekla software after we've built the model. Once we've achieved that, it demonstrates down automated from the Tekla software immediately into our factories and onto the production lines. It generates our cutting tags and also then ends up being fabricated. The advantages of using Tekla as a rebar modeling system is that it entails very, very accurate information. A lot of other softwares that we've used, we went to the worldwide market looking to see what was the best software available on the market at the time for 3D and for BIM. 18 months ago we embarked on that. After testing a few of the software systems, we were very, very confident that Tekla software would be the software that would demonstrate our business. From the most intricate jobs to the easiest projects, it enables you to save money on a daily basis in prefabrication, in waste, in design engineering, and in add value. The rebar drawings and schedules are extremely descriptive and very, very easy to read. The schedules are very, very easy to import. So there's actually a main area of efficiency and savings there as well. For Rebar Calloff and concrete pour management, combined by using and coordinating with our clients, we plan the project, program the project, so it's actually a cost evaluation before you build it, and then we detail the rebar to the specific pour layouts that the contractor requires against his program. The model is a Calloff based installation, so as the model is received on site, the rebar has been called off. There is no need now for paper schedules and highlighters. Hours upon hours upon hours of engineers' time is spent highlighting bar marks that are requested to decipher, yes, we want this, no, we don't want that. By actually clicking on the model, you can identify the elements that you want to receive and call off the rebar directly from the model. It's a live process, and any change that you make affecting it on the BIM site actually comes straight to our office, and your call off is generated immediately. So it's a very, very accurate way of calling off rebar, but it's also a very efficient way of calling off rebar. There's not endless hours spent in an office anymore. It's actually way more efficient, and in the space of 20 minutes you can call off the guts of the whole building. How do we track the rebar in Tekla and manage our materials more efficiently? Well, with Midland Steel and Tekla combined, we have generated a system whereby we get our model and model it. We're in the process at the moment of creating a QR coded version of a tag. What this was enable us to do is, after the steel has been manufactured and is ready to ship, on our tag system going forward, we will have a QR coded system whereby when the material is received on site, firstly, it's a checking process, so all the steel is there. The general day-to-day queries that we get on our phone is, we didn't get this or we didn't get that. We are able to prove that they've got the material. So it saves downtime on sites. It scans with a webcam or iPad system, and it actually identifies, after we've built the model for the client, where the material is actually for within that model. So we can demonstrate that the rebar on that bundle is now eliminated by all these multiple call-offs that we get from customers. That can be now ruled out, and the actual tag will identify and become the multiple call-offs, therefore enabling us to cut and bend the material a lot more efficiently and demonstrate a lot more efficiency on site, whereby the material is actually lifted to the area of fabrication. As you can see, the rebar is located in the model when it's read the tag, and it shows you exactly where to put it. It also, by using the model, enables you to carry forward your valuations on a daily basis. So you're able to create reports on a day-by-day basis as concrete is as built, as poured, as fixed. One of the projects that we started to use the Tekla software on was London Bridge. And in collaboration with the contractor and the engineer's designs, we decided to sit down and just have a proper planning exercise as to how we could provide a service to the client for a very, very intricate element that was going to be built in the project. So as you can see on the left hand side, we have our design intent from the engineer. These are initial sketches of what an engineer's mindset was as we started to talk about doing a 2.5 meter deep pile cap. Everybody in the room will know how these are actually built. What you can see on the model is the actual elements in rebar and the actual elements to be constructed. The design intent initially was shear links at 150 centres on a 2 meter deep raft in H20. And there were multiple things to take into consideration here. Firstly, and our initial thoughts were health and safety. How is this going to be fixed efficiently, and how is it going to be fixed safely? So for us to demonstrate to the contractor number one and the engineers number two our ideas of how we could make this happen, by not just using the initial 2D drawings and design, we went forward with a model, we created the model, and then we showed them what we thought was a prefabrication solution, which we estimated was going to be extremely efficient, save a lot of time on site, and as the number one priority was, become very, very conscious of the health and safety element. So we sat down and created a video on the model, which is available within the software. And as you can see in the bottom right hand corner of the screen, the initial design was shear links, as I said, at 150 centres. We decided to make them in a cassette form, in a beam format. So effectively what we did was we did away with all the manual labour and the cutting and bending and the fixing of all the shear links, and implemented a system whereby we were dropping in cassettes on top of a double bob base mat. We provided 3D drawings for the fixers on site, which were extremely easy to use. So instead of a fixer going through endless amounts of drawings, if you often watch a fixer foreman, he goes over and back across the deck 20 times a day reading the drawings. This guy had a 3D model. He had to look at it for 5 minutes, and he fixed 120 tons in a pile cap in 3 days. We then had the challenge of designing in Tekla a column that had no dimension or angle or shape in rebar the same. It's over 4 meters high, it's over 4 meters wide, it's 2.5 meters wide in the center, and it's sloping in 2 directions. Had we done this in 2D BBS format, we would have cut and bent the material incorrectly, it would have been sent to the site, and it would have been returned saying the cut and bent yard got it wrong, or the engineer got it wrong. And the fixers would have spent 3 or 4 weeks wasting their time trying to fix something that wasn't fixable. The circumference in one direction was achievable in 2D, but as it was sloping into 2 directions, it wasn't possible to schedule it in CAD. We identified that by using the model. We then went forward and designed a system where we prefabricated the column off-site, much safer, and then lifted the column into position. The column was transported overnight and was lifted in 40 minutes. This kind of work you won't do with 2D. This kind of stuff you'll never do without 3D proper software. For us as a company using Tekla, this is where we're getting the added value engineering. By being able to explain to the customer and show them visually before we actually do the project, before we actually take it on board, what it's going to end up like is the tender secured. So as you can see, fabricating and producing reinforcement from the model ensures seamless production and fit up. Without having the model to prefabricate these elements, it probably wasn't possible. We would have done the same thing as the fixers would have done on site. I come from a fixing background. I'm a fixer myself. I know what it's like to be on the other end of a 32mm bar going wrong. It isn't so pleasant. So, and neither are the words that come from you. But when we were able to use the model, identify the problems before we carried out the works. That's the key here. In collaboration with our customer and the engineer with an open mind, we were able to achieve something that brought the program on this project forward, ensured accurate time planning, efficiency and project management. Deliverables on the project were on time, and we are securing further work on the basis of what we've been able to do. I'd like to thank you for your attention for Midland Steel's presentation. That's enough for me.